Hi all, I'm Grishma. Here in this presentation, we will discuss some of the basics of dynamic storage management or dynamic memory allocation. So let's get started. First, we will discuss about static memory allocation. Then we will move to dynamic memory allocation. Memory allocated during the compile time is called static memory. It should be very clear that the memory allocated during the compile time or the time when the programmer is creating the program is called static memory. And the memory allocator is fixed and cannot be increased or decreased during the runtime. If you run the program, obviously the memory which has been allocated at the compile time is fixed and cannot be increased or decreased. For example, here you can see that we have an array. Although you can see over that the size is fixed. So the memory is allocated at the compile time and obviously here the size is fixed. The programmer has fixed the size and we cannot increase this size or decrease the size at runtime. Now there are certain problems which we face in static memory allocation. If you are allocating memory for an array during the compile time, then you have to fix the size at the time of declaration. Obviously, there is least flexibility because you have to fix the size at the runtime of declaration itself. This size is fixed. User cannot increase or decrease the size of the array or any object at the runtime. If the value stored by the user in the array at the runtime is less than the size specified, then there will be wastage of memory. Let me tell you that here I am talking about array. It could be any object. So if the value stored by the user in the array at the runtime is less than the size specified, if the user and the elements less than the size specified, then obviously there will be a wastage of memory. If the value stored by the user in the array at the runtime is more than the size specified, if he or she enters more elements in the array, then the program may be crash or misbehave. Here comes some to rescue. The one who can solve the problem is dynamic memory allocation. The process of allocating memory at the execution is called dynamic memory allocation. You are allocating the memory at the runtime, so users has the flexibility. He or she can allocate the memory according to his or her needs. You might have remembered this diagram from C programming. This is nothing but a memory layout of C program. There are different memory segments. The one which we talk about here is the heap memory segment. Heap is the segment of memory where dynamic memory allocation takes place. Unlike stack where the memory is allocated or deallocated in a defined order, heap is an area of memory where memory is allocated or deallocated without any order or randomly. In stack, everything is defined in order. You have to enter the element at the top of the stack. You have to delete the element at the top of the stack. Everything is well defined and everything is in the order. So memory allocated or reallocated in a defined order in the case of stack. But in the case of heap, there is no restriction as such memory is allocated or deallocated without any order or randomly. There are certain built-in functions that can help in allocating or deallocating some memory space at the runtime. Before revealing those functions, I would like to discuss one very important point. Pointers play an important role in dynamic memory allocation. Allocated memory can only be accessed through the pointers. The only possible way which we can access the memory allocated dynamically is through pointers. Now there are certain built-in functions that I was talking about. Malloc, calloc, realloc, and free. These are the built-in functions which is used to allocating or deallocating memory dynamically. I hope you are enjoyed this video. Thank you for watching this presentation.